Hello everybody, hopefully you're having a happy day. We're going to learn section 3.1. Thanks for joining us to watch the video. Make sure you're taking notes along with me, and then there's a homework assignment out of the book at the end. Alright, first thing, just a few things to let you know about radicals. We'll be taking even radicals today and odd radicals, which you've already kind of done already this year. We have done square roots, which oftentimes had two solutions, and we've done cube roots, which always have one solution. So we're going to explore properties and how, mainly, number of solutions each of these radicals would have. Anytime you are taking the even radical of a number less than 0, so an even radical of a negative number, then basically you're going to have imaginary solutions, but you're not going to have any real solutions. So an even radical of a negative number would be no real solution. And those are called roots too, no real roots. Anytime you're taking an even radical of the number 0, like the square root of 0, for example, the answer is 0. Easy. And then anytime you're taking the even radical of a positive number, you would have two solutions because you have to include the positive or negative symbol. So plus or minus your solution, meaning you have two real solutions. Feel free to pause the video at any time if you feel like I'm going too fast and you need time to catch up and write down what I'm doing. Alrighty, odd radicals are very easy to work with, such as cube roots, fifth roots, 7 roots. Anytime you're taking an odd radical, you're going to have one solution. So it doesn't matter if we're taking the odd radical of a negative number, the odd radical of 0, or the odd root of a positive number. No matter what, you're going to have one solution. And of course, 0 is one solution. It's the number 0, and then one solution. All right, let's look at some actual real examples for each scenario we spoke of on the last two slides. Let's say that I'm going to take the square root of negative 16. We actually did this earlier in the school year, back in the chapter where we were talking about imaginaries, but the solution would be positive or negative 4i, which means there's no real solutions. No real solutions. They're both imaginaries. Let's say we're going to take the square root of 0. That would just be 0. And then let's say we're taking the square root of 16. Our answer would be positive and negative 4, which does mean there's two real solutions. All right, let's do some odd radicals. Let's take an odd radical of a negative number. How about the cube root of negative 27? That would be one solution, and it just happens to be negative 3. So just a reminder, your cube root button is math 4 to find that button, and you can type this in if you want. The cube root of negative 27 would equal negative 3. That's one solution. The cube root of 0 would be 0, which is one solution. And the cube root of 27 would be 3. So all three of these have one real solution. One real solution is what this is trying to write over there. I'm right at the edge of my board. It's supposed to say one real solution for all three of those. Okay? I'm not going to write very well. One real solution. All right, we have a few example problems. The instructions are, find the indicated real nth root of A. So nth root means you're going to take this n value and make that your little radical jail guard. So this is going to be a cube root. So we're going to take the cube root of negative 216. We're going to have one solution because that's an odd root, but go ahead and type it in your calculator if you need to. Use that Math 4 button. And it's going to be a negative 6. All right, we get to, on our next one, our n value is 4, so we're going to be taking the fourth root of 81. This is our first time, I believe, this year ever doing a fourth root. So I'm going to show you where the button is in the calculator and how you can do that. So we're going to do the fourth root of 81. Grab my calculator, get out to my home screen. All right, so I do actually have to hit the 4 first to tell the calculator this is going to be a fourth root. And then you're going to go Math 5. See how that 4 just jumped into the root, into the radical symbol, so it's a fourth root of 81. That's how you would type it in. Now the calculator is going to tell you the answer is 3, but since that was an even radical and 81 was a positive number, there's 2 answers, and the answers are positive 3 and negative 3. And I'll show you why mathematically that is true. 3 to the 4th power equals 81. And guess what? Negative 3 to the 4th power also going to equal 81 because there's an even amount of negatives, so it turns the final solution to a positive, positive 81. All right, so hopefully you found that button in the calculator. If not, you can pause the video and have a neighbor help you. All right, so let's talk about when you have fraction exponents. It's kind of cool what you can do with these fractions. On our first example, they're just going to be variables, but our second example, they will be real numbers. So what you can do, if you would have a to the m over n power, is I like to draw little arrows. The top numerator is going to go this direction, and the bottom numerator is going to go this direction. So the n is actually going to become the radical of a, and the m is actually going to go to the right and become the exponent to the whole scenario. So this final would be the nth root of a, all raised to the m power. Which is kind of silly with 3 variables, but it will make much more sense when we put numbers in the position. So let's try 25 to the 3 halves. The 3 is going to head to the right, the 2 is going to head to the left, and the 2 will become the radical for the 25. So it's going to be the square root of 25. All of that being raised to the 3rd power. So as with anything, you will start on the inside of your parentheses. The square root of 25 equals 5, and then 5 cubed is 120. We're just going to deal with the positive answers for this one, because I realize the square root of 25 could be a negative 5, but we're just going to do the positives. All right, let's do some fractional exponents that are negatives. All right, I know the negative is just kind of out front, but I always take the negative with the numerator, so I'll deal with this one as though it is a negative m over n. And I'll deal with this one as if it's a negative 3 over 2. That way we're not attempting to take a negative radical, a negative root. All right, so just as before, we're going to take our numerator to the right, we're going to take our denominator to the left. This will be the nth root of a raised to the negative m power. This one, we're going to take our negative 3 to the right, our 2 to the left. So we'll be ending up doing the square root of 100 to the negative 3rd power. So let's start on the inside. The square root of 100 is 10, and 10 to the negative third power. Hopefully you remember my little jingle. Flip and make it positive. So flip and make your exponent a positive. 1 over 10 to the positive third would give me a final solution of 1 over 1,000. All right, I would say go ahead and pause the video and try the next two on your own. And then when you're ready to check the answers, you can click play. Maybe check with your neighbors around you before you click play to check the answers. Pause the video and try them by yourself. All right, you're back. So let's see how you did on the first one. Did you make it a square root of 16 to the third power? The square root of 16 is 4, and 4 to the third power is 64. And then the second one, you should have made it the fifth root of 32, which is interesting. We haven't seen that yet today. The fifth root of 32 is basically asking what number to the fifth power would be 32. And it's 2, because 2 times 2 times 2 times 2 times 2 is 32. If you need to type it in, you can. You would hit 5. I'll go ahead and just do it. You can see 5, math, 5. And I put my 32 in there. Could get you 2. But now we've got 2 to the negative third. Flip and make it positive. So make that 3 a positive, and then 1 over 8 is our final solution. Alrighty, our next 3 are all going to be done in the calculator. We've got 9 to the 1/5, 12 to the 3/8, and then we've got the fourth root of 7 to the third power, which they kind of already showed you. The easiest way to type that in would probably just be to bring that 4 back to the denominator of the 3. So do what we had been doing in reverse. So let's just type these in. They're pretty easy to do. 9 to the 1/5 would just be 9 caret 1 divided by 5. That's 1.55. Again, just round to the nearest hundredth. If you all just round to the nearest hundredth all the time, it'll be easier to compare answers. 12 to the 3/8. 12 caret 3 over 8. 2.54. And then 7 to the 3/4. 4.30. So hopefully that's going well. If not, pause the video and talk to your neighbors about the calculator usage. All right, this is interesting. They're telling us to evaluate the expression without using our calculator. You're probably looking at this 4 to the 5/2 and thinking, what? There is no way I could do this without my calculator. But you can if you use the tricks that I showed you today. So we've got 4 to the 5 over 2. And if you remember my trick, it's take the 5 to the right and the 2 to the left. So the 2 becomes the radical, so it's the square root of 4. And the 5 becomes the exponent. Now we all know that the square root of 4 equals 2. But now we add on the 5th as the exponent of the 2, and we just have to calculate 2 to the 5th. 2 times 2 times 2 times 2 times 2. And if you think about that, I'll let you think about it for a second. It is going to be 32. And then same deal here. I'm going to put the negative sign with the numerator, so I have it with the -1. I'll take the -1 to the right and the 2 to the left. I use my parentheses so I can calculate out the square root of 9 first, which is 3. I still have the exponent of a -1, so I'm going to flip and make it positive. Flip and make my exponent a +1. All right, you guys are doing awesome. We just have a few left to do. They're all going to be equations that we're going to solve together. All right, so our job is to solve for x. So we definitely want to include all positive and negative possibilities since we're solving for an unknown variable. Go ahead and write down the problem. 4x to the fifth equals 128. Do you know what our first step is going to be if we're trying to isolate x? We're going to divide both sides by 4. That would leave us with 5 to the, or x to the fifth power equals 32. Now, we're definitely to a point where we've never been quite yet this year. If this had said x squared equals 32, we'd square root to finish. But since it says x to the fifth equals 32, to finish this off, we're going to use a fifth root. Because fifth roots and fifth powers are inverse operations, it would cancel each other. So we're going to do the fifth root on both sides. These would cancel each other, leaving us with just an x on the left. All right, this is an odd radical, which means we only have one solution. And the fifth root of 32, if you need to type it in, do it. We just saw it a couple minutes ago. The answer is 2. And just a reminder, if you want to check your answer, you can go back to your original equation and put it in for x. 4 times 2 to the fifth. Just type it right in, you'll get 128. It's a great way to check. All right. Go ahead and write it down. Parentheses, x minus 3, close your parentheses, to the fourth power equals 21. All right, we can't move that 3. We can't do a plus 3 until that binomial does not have the exponent of 4 anymore. So we're actually going to start off by doing a fourth root on both sides. So we're going to do the fourth root of 21. That would cancel the fourth power, leaving us with just an x minus 3 on the left. Let's head to our calculators to see what the fourth root of 21 is. So 4, I know. 4 math 5, and we were doing it for a 21, I believe, right? All right, so the fourth root of 21 is 2.14. Positive or negative 2.14. Don't want to forget that. So we just took an even radical. Now, to finish off from here, we're going to move our 3 to the other side. Now here's where you really got to be a smart person. You got to think a little bit. We'll be taking a positive 2.14 and adding 3. You should be able to do that mentally. Positive 2.14 plus 3 is positive 5.14. But there's another solution, isn't there? We need to take negative 2.14 and add 3 to it. And that's going to give us our other possibility, 0.86. Alrighty? It's kind of similar to the quadratic formula where you have to have 2 final answers at the end. All right, our next problem has to do with weight of some coral cod. We've got the equation here, but that's the equation that can be used to approximate the cod's length in centimeters. So L stands for length, W stands for weight in grams. It's telling us that we know the weight is 200 grams, but we need to estimate the length. So our 200 will go in for W on the left-hand side of the equation. We've got our 0.0167 L cubed on the right-hand side of the equation. What do you think the first step is going to be to solve for L? What number should I move first? If you said divide both sides by 0.0167, you are correct. So divide both sides by 0.0167. I'll give you a second to type that in your calculator. It should give you 11,976. And that's going to make our last step be cube rooting. Now, a cube root is an odd root, so we only will have one solution. So go ahead and cube root that number. And this is where I kind of use the answer button trick. I do math 4. Then I hit second negative key to throw that previous answer in there, 22.88. And that's a length, so I believe that was in centimeters. Yep. I'll show you what I was talking about with that answer key trick. Here is what I had done on my handheld calculator that you didn't see. I started off by doing my 200 divided by 0.0167. And then if I want to cube root that big number, I can just do math 4 and hit second negative key. See how it says ANS? That's throwing that previous answer under the radical. It's throwing the 11,976 number under the radical. It's including the decimal. So it'll be a more accurate answer by doing it with this method. There's my answer, 22.88. All right, well, you guys did awesome today, so we're going to go ahead and stop the lesson here. Go ahead and pull out the books. There's a bunch of books under your desks, and get started on the homework. You are more than welcome to kind of discuss answers with your neighbors, but make sure you are working. And I will see everybody later. Thank you for listening.